We now move on to FOSS Earth History Investigation number 4. And FOSS, in their attempt to be witty, has named this My Sediments Exactly. You may or may not like those type of puns, but that's the way it is. Anyway, so Investigation 4 is the longest of the investigations, and it will take approximately 2 weeks to complete. There are 6 parts to the investigation. I'm going to briefly cover the first 2, and then spend most of my time talking about Investigation Part 4, Part 3, because that has a lot of setup considerations for you to think about. And then I'll briefly cover 4, 5, and 6. The Investigation 4 begins with what is undoubtedly the noisiest activity you'll probably do all year. Students, if you remember, Investigation 3 talked about the sedimentary rocks of limestone, sandstone, and shale. And so we again bring up the topic of sandstone. Students have pretty much made the link that sandstone has something to do with sand. So you offer them a question: which came first, sand or sandstone? Matter of fact, this is a pre-write activity that they will write in their notebooks. Once they're given this question, and again, you do not give them the answer at this point, students are introduced to a new type of rock. You tell them that they are being given a piece of granite, that it is not sandstone, and that it is often found in mountains, for example, in the New England area. You do not want to tell them that this is an igneous rock. They are not introduced to that term at this point in time. But you just want to emphasize it is not sandstone. They are then given the challenge to take these pieces, and they figure out pretty quickly that they can take these pieces, put it in the plastic jar shown, and shape them. What will end up happening is they're basically smashing these rocks into each other, and they will produce their own homemade sand. They will then compare them to real sand samples. But a word of caution: this activity can get extremely noisy and can also get a little bit out of control. So you want to set very clear expectations right at the beginning in terms of how energetic they can shake these rocks. And I like to display an on-screen timer with exactly how long each student is allowed to shake the jar for before they pass it on to their partner. Otherwise, you invariably get, as middle students will do, they will fight or argue about who gets to shake the jar and make as much noise as possible. Once they then generate their own sand samples and they compare it and they determine that they've actually made sand, that then leads into part 2, which is where they look at other sand samples. This is just a photograph of the way that they do it, and the kit goes into more detail about how to make this. But they take an index card, fold it in half, cut out little triangles. When they open it, they can then put pieces of tape over here. And when they flip it over, that allows them to stick the different sand samples that you give them right onto the card. So that way they don't lose the sand, and allows them to examine the sand samples. They're being given sand from different locations like mountain, river, beach, and so on to compare them over time, because they're leading to the process, to the processes of, eventually they're going to be talking about weathering and erosion and looking at how over time rock particles can be broken down and braided and end up having more of a rounded appearance and so on. So that's what this is leading towards. That then leads them into part 3, which is the stream table. What I have here is I want to show you a video about how to set up the stream table, because there's some considerations you want to think about as you prepare for it. So let me play that video for you right now.
So now I'd like to show you how to set up the stream table, or at least walk you through the process. All of the materials for this part of the activity, which comes in the latter part of Investigation 4, come in the kit. There's nothing else that you need to provide. What you'll have the actual green stream table tray. You'll get some sand and powdered clay, a basin, a wood ankle, some tubing with an eyedropper already inserted into it, a clamp, and a few binder clips. And the instructions are pretty straightforward. However, there are a couple of things I'd like to point out to you as you're setting this up. The instructions tell you to take the dry materials, the sand and the clay, and add them into your basin. And then just mix it up thoroughly. That part's pretty straightforward. However, the instructions also tell you to add about 1 liter of water, and then after the dry ingredients are mixed together. I would caution you not to do this all at once. In my experience, it's best to add about 3/4 of that amount initially. Mix it up. Again, I think the instructions tell you to mix it with the wood angle. However, it's much easier and faster if you do it with your hands. However, this is going to be like using sandpaper on your hands, so you might want to use protective gloves. You want to add about 3/4 of the amount of water, see what the consistency is, and then keep continually adding so you get the right consistency. It should be like cookie dough. It should not be soupy. If it's soupy, it could take up to a week to dry to the correct amount for it to be useful in your class. Once the wet mixture is ready, you will then transfer that wet mixture into your stream table. The stream table has an end with a hole in it. That's the drainage end. And you're going to set up the sand clay mixture in this upper part. And it's going to be about a third of the way from the back. You're going to set it up. You're going to mold it with your hands, make it as flat as possible. And you can use this wood angle to brace it and get a nice, flat, rectangular surface. And that usually takes about a day or two to dry, again, depending on how wet it is when you start off. Once that's set up, again, the instructions are pretty clear on how to set up behind it a raised platform with a bucket filled with water, for example, and how to create a siphon using your tubing. So I won't go into too much detail about that. However, one part that I found tricky when I first started teaching the kid was how to get this tubing to actually deliver the water correctly to the stream table. So the instructions say to use one binder clip. However, you'll be getting a number of them, or you might have some in your classroom, obviously. Set them up like this, where you have your one binder clip, and just put the other binder clip kind of under the top portion, so they kind of piggyback on top of each other like that. I find that this makes it much easier to then insert the tubing with the eyedropper tip at the right angle. And when your clamp is installed properly, you can then deliver the water. You can adjust how much water comes out of this hose and get the correct flow rate. So again, that's pretty much how to set it up. The biggest caution again I have is make sure you don't add too much water to the mixture, or it'll be too soupy. And to just play around with this, make sure that you know how to control this flow and you get the right flow rate before you actually do this in front of your students. It's a little bit of a time intensive at the front end in terms of preparation, but once you get this set up and running, and the students can actually observe the landforms that evolve over time in this model of the Colorado Plateau, it can be a really rewarding lab experience.
So there you have it in terms of setting up the stream table. Again, just want to reiterate, try it out ahead of time because it is a little bit tricky and does take some time to set up. After the students observe the stream table and they see the landforms evolve and they start to build up their own understanding of what's happening with weathering, what's happening with erosion, they'll then actually watch a video on weathering and erosion to give them some of the terminology and vocabulary. Again, I want to caution you, as with the River Song video, this video is a little bit dated. It is a little bit slow and not as flashy as some more the modern videos that our students are used to watching, but it does have a lot of good content in it. But if you can find a better video that offers the content with weathering and erosion, go for it. Students then move on to part 5 and part 6, where they make sandstone and shale in these plastic basins. They'll actually mix sand. For example, they'll take sand and they'll mix it with a binding agent. Here it is right here, sodium silicate, and that will serve as a model for sandstone. They'll lay that down the bottom part. A day or two later, they'll make their own model of clay, shale using clay, and that'll form a hard layer on top of that. So they'll have sandstone and shale modeled in the basin, and that will end with investigation 4. I do want to make a safety note here. Sodium silicate, and the guide does talk about this, is something you want to make sure that you're the one who's taking care of this. The kit does allow the students to add it to the sand. I don't particularly feel comfortable with this because as it dries, it actually forms very sharp edges and can be almost glass-like in nature. So I tend to keep it away from the students for that reason. And that ends investigation 4. In the next video, I'll talk about investigation 5, where the students will make layers of limestone.